In this video, I'm going to walk you through how to set up your own Chainlink Oracle node from start to finish on Google Cloud Platform. Oracles are especially cool because you can create a node to become a provider to be bringing offline real-world data onto blockchains such as Ethereum or Poly. And Chainlink providers are allowed to charge a fee denominated in Link for each remittance or fulfillment. So this means we can spin up a service through Chainlink to provide any real-world arbitrary data to blockchains, such as the outcome of sports matches, the weather in any given region, capital market prices, or even just a random number. We can then turn around and charge, say, $10 for each oracular call to our node and start earning passive income in a completely scalable and metered fashion. But more importantly, we can start dropping the word oracular at social outings. And let's be honest, who doesn't want to drop the word oracular at their next social outing? Oracular. But first, why do blockchains need oracles? In the context of crypto, an oracle is just a service that connects a deterministic blockchain with off-chain real-world data, such as weather forecasts. So one might reasonably ask, why doesn't Ethereum just ask weather.com for that data? But blockchains can't do this. See, blockchains are isolated, secure networks, and they can't do anything off-chain. And an important characteristic to note about blockchains are that they are fully deterministic. And determinism is the concept that events within a given paradigm are bound by causality in such a way that the state of events or an object are completely determined by prior states. What this means for blockchains is that if you were to go back to the genesis of any given blockchain and rerun all the transactions, computations, cryptographic signatures, you would end up in the same final state. And it's this determinism that ensures that disparate nodes won't fork as they update their instance of the blockchain. In fact, recreating the current state of a blockchain is usually a requirement for setting up a wallet or an address on most major blockchains. See, there is no randomness or subjectivity within deterministic blockchains, and that's what leads to the heightened security and ability to reach a consensus. But the problem becomes exactly that. There's no randomness or subjectivity in blockchains. So you couldn't, for instance, even generate a random number. So Solidity code, for example, which powers the Ethereum blockchain, can't actually generate a secure random number. And this is where oracles come in. So let's step through an example. Let's assume Alice and Bob want to bet on the outcome of a sports match. Alice bets $20 on Team A, and Bob bets $20 on Team B, with the $40 total held in escrow by a smart contract. When the game ends, how does the smart contract know whether to release the funds to Alice or Bob? The answer is it requires an oracle mechanism to fetch accurate match outcomes off-chain and deliver it to the blockchain in a secure and reliable manner. So one might ask, well, why don't we just create a service to take the outcome of the sports match, write that data to the blockchain, and then allow the smart contract to read that data and execute accordingly? But let's think about it. If the smart contract was governing large enough sums of money for, say, financial institutions, then we would be incentivized to tamper with the API sourcing the results of the match. Or we might create a node to write incorrect data faster than anyone else in order to cash in on our smart contract. And this is where something like Chainlink comes in. They basically say, yeah, we'll source the real-world data to the blockchain, but we're going to do it in a way that is also secure by incorporating the following principles. First, Chainlink is open source, so it would be obvious if the system was flawed or nefarious in any way. Second, Chainlink is decentralized, so you couldn't have a single bad actor mess with the results of Chainlink data. Third, they introduced the concept of performance ratings. So if a node has performed poorly in terms of uptime or data, then that node could be downgraded. They also incorporate a number of additional guiding principles. So now back to our example. If Alice and Bob decided to use Chainlink as the data source to execute their smart contract, then they can be assured that that data is going to be secure and unlikely to be compromised. Real quick, if you're liking this video, go ahead and click that like button. Thank you. Okay, so I am in my Google Cloud Platform account. I would advise you to create one of your accounts. All new accounts get a $300 credit, so you can use that for some of the tools that we're going to enlist here. And really all we're going to use is the SQL Cloud service. Specifically, we're going to create a PostgreSQL database, and then we're going to use virtual machines to create a public server instance where we can expose our Chainlink node. So let's actually go ahead and create our database first. So in Google Cloud Platform, I'm just going to go over to the menu here. I am going to select SQL, and we're just going to step through creating our PostgreSQL database. We're going to do create instance. So I'm going to go over and select PostgreSQL, and I'm going to give my instance a name. So I'm going to do ChainLink Demo. And then we can use the default PostgreSQL version and default region. That's fine. So we're going to go ahead and create our instance here. And then next we want to take a look at databases. So let's see here. Instance is being created. This may take a few minutes. I think it's going to give us a default database. So let's give it a second here for it to spin up. Okay, so while the database is spinning up, let's go ahead and create our virtual machine. So we're going to come over to Compute Engine, and we're going to do create instance. And there are some minimum requirements that we need to adhere to, but it's pretty low. I think it's 2 cores and 4 gigs of RAM. So this is 2 cores, 4 gigs of RAM. I want a little bit more power. So I'm going to select 8 CPU, 32 gigs of memory. And then let's go down to operating system and boot disk. 10 gigs of storage is not that much. So let's go ahead and throw 100 in there. And then for operating system, I like Ubuntu personally. So we're gonna go ahead and do Ubuntu. And I think we are gonna want x86-64. Probably do it with ARM architecture. I just haven't done that and I don't wanna speak to it. So we will use this configuration here. And I'm also going to select allow HTTP, allow HTTPS traffic. We're gonna go ahead and select create. Okay. And we want to grab the public IP address of this virtual machine. So I'm going to go ahead and click copy here. And what we're going to do is we're going to go back over to our database real quick. And it looks like this has been created. So we're going to step into it. And basically, we want this database to be able to make a connection to our virtual machine. The virtual machine is the actual operating system that's going to run the Chainlink software, but the Chainlink software requires a database and it wants a PostgreSQL database. So it's going to need to talk to this cloud SQL database here. We could have put our PostgreSQL database right on the server, but I don't want to set up and manage all that. I don't really know how to do that. I certainly don't know how to scale it. That becomes a requirement down the road. So that's why we're enlisting Cloud SQL from Google. So let's come down to connections and let's go to add network. Basically what we're doing here is you need to allow list the origins that you want to be able to talk to the SQL database. So we're saying, hey, allow the IP address, that's the origin of our virtual machine. And we can just call this Chainlink VM. And I think that's all we need to be able to allow them to establish a connection. So we're gonna go ahead and click save. And another thing I wanna look at here is users. So let's let that edit finalize. Okay, so now we wanna create a user. So in order to connect to a database, you have to create this concept of users, which is essentially credentials. So we're gonna do add user, and we're gonna do data slayer user. Okay, so now we have a user. Our connection is set up. Let's take a look at our actual database. So it created a default database, but let's create a new one specifically for Chainlink. So we're going to call it Chainlink DB, and we will do create. And so now we have that database there. So we should be good on the PostgreSQL front. Let's go ahead and set up the software on our virtual machine. So we're going to go back over to Compute Engine, and we're going to go ahead and connect to our instance over an SSH terminal. And I'm just gonna make this full screen for ease of use. Okay, so now we wanna see, is Docker installed? So we can do docker ps-a. That's the command that will list any containers we have. We have no containers, but it did respond to the command and began to list out the table, the column headers here. And we could do the same for images. Again, we have no images, but at least it's responding to the command. So basically Docker is installed. So what we want to do now is set up we're going to want to download the Chainlink Docker container. But before we do that, because we can do that all in one go, we can download the container and we can execute the container and run it, which is going to run Chainlink. But before we do all that, let's actually stage. Let's create a staging area here. There are different chains or environments that we could run Chainlink. There's like the test nets and then there's the mainnet. We're gonna run this on the mainnet just cause YOLO. So let's make a directory, mkdir chainlink, and we're gonna step into it. We're gonna create a configuration file essentially. So let's do vim and we're gonna call it .env. And this is where we pass some of the parameters that the software is going to use to process. So we're going to take this here and we're going to paste that in here. We're going to get rid of this. Oops. I'm just using Vim here. You can use Nano or Emacs as you so choose, or if you want, you can use like Visual Studio Code or something like that. So these are the variables that we want. Root is Chainlink. Log level is debug. ETH chain, this is where I was talking about before, the different test nets. We actually want one, right? Because we want mainnet. Secure cookies false, allow origins, wildcard, that's fine. Okay, so we made the Chainlink directory and then we added this file here. We're running our Ethereum client remotely. So we're gonna use, so you need to have an Ethereum node as well. But we're instead of running our own node, because trust me, that's a pain in the ass, we're going to use Alchemy, which provides Ethereum nodes kind of as a service. Okay, so this is where we define our Ethereum node. So let's go ahead and do that. So I'm just gonna add another line here, and we need to get our ETH URL. So this is where we're gonna come over to a service called Alchemy. So you can just search Alchemy, it's alchemy.com literally. And we're just gonna create an account here. This will be free. Again, similar to Google Cloud, they give you some credits to play around with. So we're gonna do login, or we're gonna create an account here. Okay, so now we have our Alchemy account and we're gonna create an app, and we want Ethereum mainnet. So we're gonna do data slayer Chainlink node. All right, so this is setting up our Ethereum node, which trust me is a big process if we were to do it ourselves. That's why Alchemy is so helpful here. So now let's step into our node here, and we want to do view key, right? So this is the ETH URL that Chainlink was referring to. You can use HTTPS or you can use WebSockets. I believe WebSockets are more performant. So we're gonna copy that, and then we come back over to here, and where it says change me, throw this guy in there. And so what's happening here is this is the origin for the Ethereum node, and then this P underscore thing points it to our app. This tells Alchemy, hey, send it to Data Slayer's ETH app. So we should be good there. And let's see here. Okay, so the next parameter that we have to add in is the database information. So we need to be able to tell Chainlink, hey, this is where our PostgreSQL database is. And so there's a whole schema to that URL. So let's start a new line here. We're gonna throw this in here. And okay, so we have the protocol PostgreSQL, and then it wants username and password. So remember when we created the user in Cloud SQL? That's what it is asking for right now. So I'm gonna grab that information. So yeah, I called mine Data Slayer user, Data Slayer user. And then the server, so it needs to know, where does PostgreSQL live? Well, PostgreSQL does have its own origin. So we go to SQL, to our instance. This is where it lives. So we'd grab that IP address. That is the server. And then PostgreSQL operates on a standard port, and I don't know what that is. PostgreSQL port 5432, and that's, unless otherwise directed, it will always be that port, so we can just do that. So that's the port, and then it needs to know what database to connect to once it connects to the origin. So we're gonna do Chainlink DB. So what I'd like to do though, before we start Chainlink, is I'd like to just prove that this server can connect to PostgreSQL because by default those networks are not accessible. So let's go ahead and do that. So what we're gonna do is we're gonna download a PostgreSQL client so I can actually test that connection there. So we're gonna download that right here. Again, I'll put this in the description. This is just a lightweight PostgreSQL client. And so now what we can do is there's a command by which we can test the connection. Our database name is Chainlink DB. The host is this guy here. Port won't change. And the user is going to be a data slayer user. All right, so let's run that and see if we can't connect. Okay, it says accepting connections, which is what we would like. So that means we can talk to, it means all our credentials are accurate, the IP address is accurate, and the PostgreSQL database has allow listed this origin. So we're looking good there. So why don't we go ahead and try to run the Chainlink instance. And again, we do that by way of Docker. We already installed Docker, but what we want to do is we need to download the container and run it. And you can actually do that all in one go. So when we do Docker run, it's got this information here. We want to point it to the environment. Let's step out of that directory, and we want to point it to the folder that we created. And the folder is called Chainlink. And I don't know what the tilde and all that is. So we're just going to say this is the relative path. So dot means the current directory, dot /, and then down one would be the Chainlink directory. And then it's going to look for this file, .env, which we have set up, and then it's going to execute this Docker image. Now, it needs a version, it needs a tag. So let's see what tags we have available for us here. These are the different tags, right? Let's do root, because root sounds promising. So we're going to swap out that for that. That's saying of all the Docker images, let's use this Docker image here. And I think that may be it. So again, we're gonna download the Docker container. We're gonna run it. The Docker container is gonna look in our Chainlink directory. It's gonna pull the environment configuration variable. It's gonna see that we're using mainnet. It's gonna see that we're using Alchemy. And it's going to see the credentials and all the information it needs to connect to PostgreSQL. So there's lots going on here. It might go sideways, but we'll see. .env, no such variable. Let's actually do this. We're going to run this in the Chainlink folder here. And again, because it's a .e file, you can't see it with regular ls. So it's downloading the Docker container, which consists of layers. So it's downloading each layer in parallel, and then it's gonna run the container. So this is actually the image. So it downloaded the image, and let's see here. Opening DB, failed to open DB, failed to connect, host, temp, root database. So it's weird because these aren't the credentials we provided for connecting to PostgreSQL. So let's take a look real quick at this. So I'm going to try exporting this as an environmental variable. Okay, so the issue is the password. Password is giving us trouble. So let's go ahead and let's make it more simple. It's really unfortunate that it doesn't tell you what the requirements are around passwords on this stuff. So we're going to do change password, and we're just going to do, let's make this a lot easier. And then let's go ahead and Okay, so it actually worked. And now it's prompting us to create a Keystore password. So what's gonna happen is Chainlink wants a password for connecting to the node. And so we're gonna go ahead and pass that password. Similar to how the password for the PostgreSQL database was too complex, I noticed that the Keystore password also has very odd criteria that's hard to adhere to. It's like, don't use numbers, 4 uppercase letters, greater than 16 characters. It's crazy. So just make sure that you adhere to those rules, or else it will accept it and then it just won't accept it and you'll have no idea why. So I'm gonna do data slayer is the best, and data is gonna be all caps. So DATA. Okay, and then we're gonna confirm it. Okay, and then you essentially need to make credentials for logging into the UI that it's gonna expose. So I'm just gonna do dataslayer@gmail.com. It doesn't have to be a real email. Okay, so it's actually running our node right now, and it's just gonna keep running indefinitely. And if we wanna get some information about our node, well, that's where we can access the Chainlink client. And it's essentially a web application that allows you to manage your node. So let's go ahead and do that. So we want to keep this running here. So I'm going to keep this shell open, and I'm going to open another shell so that we can just configure a couple things so that we can get the application to work. So the application will be exposed on the public IP address associated with our server. And let's try doing HTTP. So, okay, it's not returning anything right now. And that's because Chainlink exposes the application on port 6688. So let's see if we can't do it. Yeah, I think that's gonna be blocked. I don't think Google Cloud Platform lets you connect to any port that you want. I think you can only connect to like port 80 and port 443. And so right now it's being blocked by a firewall, and that request will time out. So we need to expose it on port 80, and we can do that. All right, so I'm logged in here. So the way we're gonna do that is we're gonna use NGINX. So I'm gonna quickly download NGINX. So we're gonna do apt. Well, let's just show you that the Chainlink app is up. So if I curl here, localhost 6688, this is the Chainlink app. It returned a Chainlink app. But I can't get to 6688 on Google Cloud Platform because I don't think, it just doesn't want you to use atypical ports, I believe. Yeah, if we want to expose an app on this server, we need to do it over 80 or 443, which is HTTP or HTTPS. So I have a way to do that. So we're gonna do apt get install NGINX. NGINX is reverse proxy server software, and that's what we're gonna use it for. All right, so we just downloaded NGINX. So now we have a web server coming back on localhost. So check it out. All right, so this is our NGINX server. So now instead of pointing to this HTML directory, we want to take the request and proxy it to port 6688, which is going to be our Chainlink app. And so what we can do is if we go over to our configuration file, it's in etc. NGINX sites enabled, and we're going to edit this default. We're going to proxy the request on 80 to 443. So a couple things here. Let's get rid of this guy. We're going to get rid of this guy. We're going to get rid of this guy. And so basically, this is the server on port 80. When the request comes through, any request, we want to proxy it to localhost 6688. And then we want to add a couple of these headers here to denote the proxy. So again, so we can request our public IP address on the virtual machine. NGINX will say, oh, request is coming in from on port 80, which is HTTP standard port. Proxy it internally then to 6688. And it will do it for JavaScript files, HTML files, all the files. Just change the port essentially. So take the port from 80 and pass it to 6688. And then once it's 6688, Chainlink will say, oh, that's me. That's my web application. Let's go ahead and return the web application. And so that is the config for NGINX. And I'm just going to restart the service. we want to reload the config, and then we want to restart the service. And with any luck, we can, okay, so hopefully that made sense. So basically now it's exposed to report 80. And if you want to put a domain name in place for a node, you can do all that. I wouldn't suggest using HTTP, I'd suggest using HTTPS. So this is the web application for our Chainlink node. So now you can like create jobs, right? And this is where you would throw some of your code. Oops, it's asking that we log in. So this is the credentials that we created after the Keystore. So it was dataslayer@gmail.com. Okay, so now we've logged in, right? So you can like manage you can check out your node, you can create new nodes, you can create jobs, and this is where you can manage your Chainlink instance. So we have our Chainlink node going, it's up, we can access the web UI. Alchemy is chugging along in the background, and that will give us some stats about how we're handling the Ethereum node client traffic. You can see that all here, and you can see requests coming up here. And so really, that's the broad strokes for setting up your Chainlink node. From there, it's about creating jobs. It's about fulfilling requests. It's about advertising your wares, like what sort of service are you going to provide? How do people find out about your service? Stuff like that. And there is a website, let's see here, Market Link, I believe it's called. And this just gives you an understanding of some of the other data providers, right? Like what nodes are up now that are providing data, right? So like SollyPay, let's see what this is doing. SollyPay is a consumer data marketplace where users have the option to share any and all of 6 data types, including location, browsing, purchases, and to make a request to this cost 1 link, right? Payment amount, and we could say, okay, price of link. Crypto, right? And it's around $7 right now, right? So it's $7 to make a request. But if the smart contract is set up in such a way that the executor takes a rake that's higher than $7 or what have you, then that can be economical for the person who has who's providing the service, right? And so that's a whole other thing that you can explore, but that's kind of how you set up your Chainlink node. As always, if you want to stay apprised of the latest around emerging tech, then go ahead and hit that subscribe button. Thanks.